In this video, we develop the derivative of the sine and cosine functions. We start from the definition of the derivative. For both the sine and the cosine, we use the standard definition of the derivative. The limit as h approaches 0 of the average rate of change, where we evaluate the function at x plus h minus the function at x, all divided by h. In order to expand these formulas, we need to use the trigonometric sum identities. So we have a formula for sine with a sum as an input, and a formula for the cosine as the sine where there's a sum in the input. Notice that the sum rule for the sine has sine times cosine and cosine times sine, whereas the cosine of x plus h has cosine times cosine minus a sine times a sine. And that subtraction will play an important part in the definition of the derivative for the cosine. When I use the sum identity for the sine, notice that we replace sine of x plus h with a formula coming from the sum identity. I've highlighted the functions that depend on x, so we have sine of x in blue and cosine of x in magenta. If I group the terms that have the same formula involving x, so that I have sine x and the cosine of x factored out, I get sine x times the quantity cosine h from the first term minus 1 from the last term. And then I have the final term of cosine x and sine h. Because of the sum identity for limits, as well as the constant multiple rule for limits, I can rewrite this getting the sine of x times the limit of the cosine h minus 1 over h, plus the cosine of x times the limit of sine of h over h. And this is why the limit rules are so important, is they help us develop the derivative rules. I'll do the same thing for the cosine. When I calculate the cosine's derivative, I substitute the sum identity for the cosine, giving cosine x cosine h minus sine x times sine h in place of cosine x plus h. Again, I've highlighted the cosine of x in magenta and the sine of x in blue, so that if I group the terms that have cosine x together, I get cosine x factored out times cosine h minus 1, and then minus sine of x times sine of h all over h. Again, using the limit rules, I can split this limit into two parts and bring the functions that only depend on x outside of the limits, so that I get the cosine of x times a limit plus or minus the sine of x times another limit. Notice that we had the same limits appearing in both derivatives. These limits are the fundamental limits required to calculate derivatives of our trigonometric functions, and they correspond to evaluating the derivative of sine and the derivative of cosine at x equals 0. In order to find the value of these derivatives, or the value of these limits that we need, let's calculate a table. So I've created an animation where I create a sequence of values for h. This is a geometric sequence so that we can see our variables converging to 0. H is going to get closer and closer to 0. And then I calculate the average rate of change for the sine, which I've abbreviated SAROC, and the average rate of change for the cosine, which I've abbreviated CAROC. And we'll watch an animation as n increases so that our sequence h approaches 0. And pay attention to the values of the sine and cosine's average rate of change and see what they approach. Notice that the closer h gets to 0, the sine's average rate of change is getting closer and closer to 1. And that's the limit. The limit as h approaches 0 of sine h over h has the value 1. And notice that the cosine's average rate of change is getting closer and closer to 0. And that is in fact the limit that we get. That the cosine's derivative is 0 at 0, and the sine's derivative is 1 at 0. Once I know these limits, I can go back and substitute them into my derivative formulas. And so I get the sine's derivative is sine of x times 0 plus the cosine of x times 1. And the cosine's derivative is cosine of x times 0 minus sine of x times 1. And when I simplify those, I get that the derivative of the sine is the cosine function, and the derivative of the cosine is negative sine of x. Remember where that negative sign came from? It came from the subtraction in the cosine sum identity. All right, I hope that this was helpful in understanding where the derivatives for sine and cosine come from. Thanks for watching.